Today's lesson is lesson 4.2, angles of triangles. Up to this point, we have talked about triangles and we've classified them by their sides, calling them equilateral or possibly scalene or isosceles. And we've also used their angle measures, like a right angle, or we call them equiangular, or even obtuse. Well, today we're going to apply the triangle sum theorem and the exterior angle theorem and make sense of all that. So today we're using some theorems to prove some stuff that we already know about triangles. So we have 5 new vocabulary words. An auxiliary line is just a line that you add to a picture in your proof. And it's always parallel, or I should say mostly parallel. It's usually parallel, so we can use that line to talk about things that we know to be true about parallel lines. So when we add an auxiliary line, we usually make it parallel to one of the bases of our polygon. The exterior angle is the angle outside of the polygon. This is just an angle outside the polygon. The remote interior angle, angles are the two angles that are opposite the exterior angle. We're not going to use a flow proof, and a corollary is just something that we prove in addition to a theorem that has already been proved for us. And I'll show you one of those in the middle of our notes. Okay, let's go. So the first thing that we have today is the triangle sum theorem. And the triangle sum theorem tells us that the measure of the angles of a triangle is 180, meaning the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. We already know this. We're going to prove the triangle sum theorem. I have a proof right here. We're going to use this to prove the triangle sum theorem. The first thing that I want to show you is this added line right here. This is an auxiliary line. You see that we added a line and we made sure that it was parallel to the base. The purpose for adding that auxiliary line lets us use things that we know about maybe alternate interior angles and things like that. So the first thing that we have is given triangle ABC, and we want to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Triangle ABC, this is given. We're going to construct line AD through A parallel to BC. Well, this is just called the parallel postulate. Remember we learned that last week. And the parallel postulate just says there's exactly one line parallel to another line through point D. So if I have point D, I construct only one line parallel to BC. It's the parallel postulate. Angle 4 and angle BAD form a linear pair, and this is just the definition of a linear pair. Angle 4 and angle BAD are supplementary. Well, that's the supplement theorem. It says that two angles form a linear pair. They are supplementary. Two angles form a linear pair. They are supplementary. Again, this is the supplement theorem. Abbreviated there. And it says that the measure of angle 4 plus the measure of angle BAD is 180. This is the definition of supplementary. Definition of supplementary. Okay. The measure of angle BAD, equals the measure of angle 2 plus the measure of angle 5. This is the angle addition postulate. It also says that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equal 180, and this is substitution. I'm going to tell you what two lines I used. This is substitution. I used line 5 and line 6. Statement number 8 says that angle 4 is congruent to angle 1. Angle 4 is congruent to angle 1. And it also says that angle 5 is congruent to angle 3. If two lines are parallel, then alternate interior angles are congruent. That's the alternate interior angle theorem. That lets us say that. The measure of angle 4 equals the measure of angle 1, and the measure of angle 5 equals the measure of angle 3. That is the definition of congruent. And the last statement says that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. This is, again, substitution. And I used lines, I replaced 4 with 1, so that's line 7. I replaced 5 with 3, so that's this as well. And then number 9, we said that they were congruent, so 4 is replaced with 1, 2 stayed the same, but 5 was replaced with 3. So these are the two lines that I used, 7 and 9, and that's the proof. All right, so we're going to look at the softball diagram. This diagram shows the path of a softball in a drill that's developed by 4 players. So we're going to use what we know about triangles to solve for the number of angles. Using the triangle sum theorem, the measure of angle 1 plus the measure of this angle, which is actually 74, plus the measure of this angle, which is 43, has to equal 180. So the measure of angle 1 is 63. Now I see that the measure, I see that angle 1 and angle 2 form vertical angles. That means that they're congruent to each other. So the measure of angle 2 is also 63. Now I know that if the measure of angle 2 is 63, then the measure of angle 3 plus 63 plus 79 has to equal 180. So my calculator, I'm just going to take 180 minus 63 minus 79, and that is 38. The measure of angle 3 must equal 38. So those are my 3 missing angles. Exterior angle theorem. This says that the measure of the exterior angle, it's right here, the angle outside of the polygon, is equal to the sum of the measures of the two remote interiors, meaning it equals the measure of angle A plus the measure of angle B. So you see here the measure of angle A plus the measure of angle B equals the measure of angle 1. So let's use that to find the measure of angle FLW in the fenced in flower garden. So I know that the measure of angle FLW, which is 2x minus 48, must equal the sum of its two remote interiors, x plus 32. And now I'm just going to solve. Subtract x from both sides and add 48 to both sides, and I find out that x equals 80. If x equals 80, then the measure of this angle equals 2 times 80 is 160 minus 48 equals 112. We have two corollaries which come from the triangle sum theorem. The first one says that the acute angles of a right triangle are complementary. That makes sense. If this is a right triangle, the other two angles must add up to 90 degrees, which means they're complementary. And then the second corollary says that there can be at most one right or obtuse angle. Well, that makes sense as well. All right, so now we're going to find the measure of each numbered angle. So we're going to use things that we know about the exterior angles. So if we look at,
For this problem, I would like you to draw the picture and find the missing 5 angles on your own.